Okay, today I want to show you a really interesting TypeScript pattern called branded types. The idea with branded types is this. We have strings within our system. This could work for numbers too and other primitive types, but it's going to be most useful with strings. So we have strings within our system that have some particular content in them that makes them a particular value. For example, an email address, or maybe it's a formatted ID according to however our system does IDs. Maybe it's a formatted date. All of these strings have particular formatting within them, but they're just strings within TypeScript. What if we wanted to give them a more specialized type, like an email address or a product ID? How could we do that and be able to pass it around through our system, knowing that this is an email address? Branded types are the solution to this. So let's take a look at some code. You're probably already familiar with type aliases. Type aliases are simply where we use the type keyword to alias one type to another. Now, often we use this to create more complex shapes, but we could even do something similar where we say an email address is just a string. So now with a type like this, I could write a function that we call send welcome email that maybe sends an email to a new user when they sign up. Now, the obvious problem with this is that I can pass any string I want to send welcome email address because email address is just an alias that accepts any string. So how could we make this really support just an email address? Now, this is where we can use a branded type. The idea behind branded types is that we're going to create a type that within the normal rules of TypeScript, no value could actually be assigned to. Now, there are lots of ways to create illegal types like that. For example, we could create the intersection of a string and a number. If we create the intersection of a string and a number, notice that the type of email address reduces to never. You can't have something that is both a string and a number, and so this becomes a never type. We're going to do essentially the same thing for our branded type, except instead of putting number here, we're going to create an intersection of string and a basic object, and inside this object, well, you can really put whatever you want. I've seen some people do double underscore type. I like to do double underscore brand. You can do whatever you want. The point is that really we can't have a intersection of a string and an object like this. And so then maybe in this brand here, we can just kind of tag this so that we know what it is. For example, we can say email address. So now we have this type that is a string intersected with this object. Now notice that this is not an actual never type, which is kind of important here. If this was a never, then we really couldn't assign anything to it. However, the TypeScript engine seems to recognize that there might be a way to get a value for this. And so we have string intersected with our brand here. We do already see a failure down here where we go to send the email address. Our type string is not assignable to the type email address. So this is kind of what we want. This string is not formatted as an email address, and so we don't want to treat it as an email address, and that's exactly what's going on in our function. Now, of course, there's nothing special about our email address type here that says we want it to be formatted as an email address. Essentially, now what we need to do is write code that will check the string to see if it is an email address, and if it is, then we can assert that this actually is of type email address. We can write another function here, is email address, and it's going to take some value that might be an email address as a string. Okay, so it's important that this is a string. Now what we want to do, and you probably can guess this based on the name of our function, is email address, is we want to return a Boolean value here, right? We want to return either true or false depending on whether this string that we pass in matches whatever our system criteria for an email address is. However, the crux of this pattern is that we don't actually just say this function returns an email address. Instead, what we can do is say email is email address. Okay, so what does this mean? We're still getting a type error here just because I haven't actually implemented the function. So let's just say return true. But what this means is that if we return true, then this statement here, email is email address, should be considered true. And if we return false, then this statement, email is email address, should be considered false. Basically, we're saying whatever argument we pass here, if this function returns true, cast it to an email address or consider it to be an email address. Essentially, we're overriding the type system and saying we know better what this type is. Now, often in TypeScript, that's a bad idea. You don't want to do that. For example, we could, in our function call down here, just say send welcome email with this string as email address. And if we just cast this string directly to an email address, then TypeScript will say, okay, if you think you know better, then I will listen to the directives you're giving me. This is a bad idea because if we do this and this string that we're putting in here is some input that we get from our user, for example, well, we haven't done any validation to ensure that this is an actual email address. Or maybe we have done validation, but we don't have a branded type, so we're still passing this email address around as a string, and we just have to assume that when we get to this call in our system, we've already done the validation for this string. Our isEmailAddress function here is going to solve that problem a little bit more elegantly for us. We're still going to tell TypeScript we know a little bit better than you do about what this type is. And we're doing that, of course, by casting email to an email address here. However, because of the way that this is set up with this function, we actually have an opportunity to write some logic here that validates that this actually is an email address. And that's 100% on us. We have to write the logic for our system that means this is an email address or a product ID or a correctly formatted date or whatever it is. But at least there is some business logic involved with casting this string to an email address. So instead of return true here, maybe I'll just say, and we'll do something pretty simple. We'll just say email includes at gmail.com. We'll keep this really simple. If that is part of the string, then we're going to consider this an email address. Obviously, there's actual regexes that you can use for this. We're just going to use this as an example. Okay, so now how do we actually use this function? Let's create another function here, and we're going to call this sign up. And this is when a user is signing up. To keep this simple, we'll just say they give us a single email address when they're signing up. We're going to ignore the passwords and stuff like that. So we have an email address. Let's actually use our isEmailAddress function. And it's pretty straightforward. We could just say if isEmailAddress email, and then within our if statement, we can actually call our function. And now if we hover over email here, you can see that this is considered an email address. So this is how we can use our isEmailAddress function here to actually cast a string to an email address. Now notice this is of course only inside our if statement here. If we bring this send welcome email call outside of this, it still considers this to be a normal string. Without a branded type like this, we have to pass these values around through our system as strings. And that means we either have to assume we've done that validation at the top layer and then just cast them to email addresses or ignore the fact that they might not be formatted within the code. Or inside that system, we have to do this validation every time we want to treat this as an email address. By moving the validation to the edges of our system and then branding the value so that we know it has gone through that validation, we give ourselves a lot of safety when we pass these types of values around. Because remember, one of the core ideas of this pattern is that there's no way for us to create a primitive value that is an email address. The only way that we can assign something to this email address type is if we explicitly cast it. And so as long as we make sure we don't do that outside of our isEmailAddress function, we can know that any value in our system that is of type email address actually matches whatever our system formatting should be. There's one other way that we can do this type of validation, and that is instead of creating a checker function here that returns a Boolean, we can actually create an assertion function that throws an error. Conventionally, we might call this something like assert email address, and instead of just returning email is email address, we can say asserts email is email address. Now, the whole idea behind an assertion like this is that if this value does not pass the assertion, then we throw an error. So instead of just returning like this, we can say maybe if the email address does not include at gmail.com, then we're going to throw a new error. Email is not an email address. So now with this assert email address, we can make the first thing that we do inside this function, assert email address. Now notice as soon as we asserted that, this error resolved itself. The interesting thing about assert's email address is that after we assert this, any further code within this function will know that the email parameter here passed that assertion, and so we can treat it as an email address. So we no longer need to do this check. So these are just kind of two different styles of doing the same thing. It really depends on how you want your system to work. You could imagine this signup function here being the handler for your signup endpoint. And maybe if we assert like this and then we can throw an error, we're actually going to convert this into a 400 that goes back to the client, something like that. And so that could be a nice pattern. If you don't need that type of pattern, then you could just stick with the more basic isEmailAddress and cast in that way. So that was a quick look at branded types within TypeScript. It's a great way to use TypeScript and input validation together to make a stronger, safer system. If you found this video helpful, I would find it helpful if you liked and subscribed. Thanks so much for watching, and I'll see you in the next one.